All right, guys, welcome to semester two. Don't let the senioritis kick you in the behind. All right, so here's what we got here. Consider the following graph. Who are the subjects in the study? What are the variables of interest? Thoroughly describe the information illustrated by the graph, choosing at least two data points to help with your explanation. So right here, if I go ahead and look at the information that I'm given here, I've got a scatter plot. And I can see here on the x-axis here, it tells me that this is the taxable income in thousands of dollars. So this would be 10,000, 20,000, 30, 40, so on and so forth. Amount of tax owed, that's what my y-axis is, and that's going up by thousands each time. And I can kind of just see this pattern right here as it's going up. Okay. So, who are the subjects of the study? Well, subjects, let's see, subjects. Subjects would be, that would be our single filers. Okay. So we have our single filers. Um, I wouldn't even say so much 2007, but I mean, we could say it's a 2007 single filers, but that's what we've got. It's our single filers. That means that it is somebody who is filing as an individual, not married, no children, no dependents, nothing like that. It's just a single individual. Um, all right. And then what are the variables of interest? So the variables of interest is what is it? What are we looking at? What is the information we're trying to figure out here? And that's the taxable income. So variable of interest would be our taxable income. All right, cool. Now, thoroughly describe the information illustrated by the graph, choosing at least two data points to help with your explanation. So, that's really open-ended and vague. There's nothing necessarily wrong. It's asking us to use at least two data points. So that would be something like saying along the lines of somebody making, let me see, like this one right here. So we could say that this would be somebody making approximately, let's draw a straight line now. Making $35,000 would have an amount of tax owed of approximately $5,000. So, that would be something that we could use as a data point to go ahead and help with the explanation. So you could say something along the lines of, we have a positive growth. I can see that it's positive because it's increasing as my x-axis grows, my y-axis is also growing, has a positive relationship. I could say something along those lines. There's no one specific right answer, but you can use any of that kind of stuff. All right, look at this new graph and discuss with your partner the information illustrated. Then compare and contrast this display with the graph in question one. So right here and this one, it goes, if we go ahead and consider various different things that we could compare here, is I can notice right now is as I'm going from right to left, so as my X values are increasing, my Y values are actually decreasing. So this is showing me a negative relationship. And so I can kind of see that, and then if I'm going like that, okay. So I can see that information. So comparing the two, one is a positive relationship, one is a negative relationship. The other one right here, if I go ahead and look at what is this even looking at? This is saying that, okay, if I have a $50,000 taxable income as head of household, so before any child deductions, my number of children, as the number of children increase, the amount of tax owed decreases. That's what this is telling us. So if you have no kids, you should be owing about $7,500 in taxes. But if you have one, well, it looks like it's a little bit less than 7,000, so we'll say about 68,000. If you have two, be right about 6,000. If you have three, be about 5,200, and four would be right about 4,400. So you can see that's what it's doing as it's going up in children, the amount of taxes owed decreases. So the more children you have, the less taxes you pay, apparently. Um, but trust me, you pay in every other way. All right, so let's go ahead and consider that. All right, so now right here with reflections. Use the previous graphs to complete the following sentences. A person with higher taxable income pays, well, if they have a higher taxable income, well, let's go up here and look at that, because this is just talking about the number of kids. So the higher taxable income, the higher the taxable income is, the more they're paying in taxes. So a person with higher taxable income pays more in taxes. Okay, so then a person with lower taxable income pays less in taxes. All right, this is an example of, as I already mentioned, a positive association. Okay, now a person with fewer children pays, so let's come up here, fewer children. So a person with fewer children, they're paying more than the person over here with 4 children who's paying less. So a person with fewer children pays more taxes, and a person with more children pays less taxes. This is an example of a negative association. So the reason it's positive is because as it increases on both, or as one increases, the other increases, is what I should say here. Likewise, for it to be negative, as one increases, the other decreases. So that's kind of what's going on there. All right. So let's see here. All right. I'll go ahead and be honest. There's some nuance to some of this terminology with various different tax things that are even beyond my scope of understanding, and I don't think I still quite understand the definition of head of household, but I digress. But we'll go with it. Here's the question that we've got here. It says, in actuality, head of household filers with $50,000 in taxable income and the same number of children could pay different amounts of income tax, as shown by the graph on the right. These differences result from tax credits for expenses such as childcare that can reduce the amount of tax owed. Compare and contrast this new graph with the original graph on the left. So if I go ahead and look at the graph that I have on the left, that's the one that we were already looking at, that, as our number of children increased, our amount of tax owed decreased. And that's what we have here. And then we can see these various different ones, and we got this one crazy little outlier there. I'd like to know their magic trick. But that's what you've got. And as it says right here, and I'll tell you some of the ways that you can reduce your tax burden from having children would be, there's something called a dependent care savings account. And you can actually put a certain amount of money into this account, and it can be used exclusively for childcare uses, but it's taken out of your paychecks pre-tax. So that way it actually reduces the amount of taxes that you owe, because that money is no longer taxed. But in addition to it, that's also just something that can be reduced off of your tax burden. That's just one example of something. Now, again, not trying to make it sound like kids are all great and grand and you save money, because you don't. Y'all kids are expensive. So let's go ahead and consider it now. Now, if I go ahead and look at the next following graph here, what information is displayed? Compare and contrast this graph with the others that you've analyzed. So now the other ones kind of seem to be a bit more predictable, if you will. It was here, it was just kind of decreasing, and same thing here, and what we had here just decreasing here. This one was kind of increasing. You can kind of just see it look more linear than anything. This is not. This one's kind of a bit more of a scatter. Got all of that going on. It also, as it increases, then it reaches a maximum and then it starts to decrease. So this has actually got a bit of a curvature to it. And you have lots of various different ones. So you have car one, car two, car three going miles per hour and their miles per gallon. So you can see like car one, if I go ahead and look at what I've got here, it's going up and increasing. It gets to about this peak right here at about 30. So it looks like 30 miles per gallon is its best, most optimum gas mileage. And it's getting that at about 50 miles an hour. That's pretty good. And then going down here, and then that's when it starts to decrease. So as you get above that, it starts to decrease in gas mileage. And then car two, it's kind of saying along the same lines, going up to 50, and then it starts to decrease back down. Car three seems to be a bit scattered. I'd honestly be a bit kind of curious to know what kind of car that one is, that it's just kind of jumping all around like that. But it's definitely an interesting thing that it's doing that, but it's just saying that that's what we've got here is we're just looking at the miles per hour as it's increasing, the miles per gallon, it goes up, up, up to a maximum and then down. So it does have a predictable nature in that all of them do increase to a maximum, then decrease. It's just not predictable in like a linear pattern. Um, all right. A survey of students asked how many siblings live in your house with you and how many pets does your family have? The results are displayed below. Comment on the graph comparing and contrasting it with the previous graphs. So if I'm looking right here, this is saying that, okay, for example, this person right here, they have two siblings and no pets. This one here has two siblings and two pets. And this person here has two siblings and four pets. So, the whole thing here is it's ridiculously kind of scattered. There's no pattern to it. I couldn't say any of this is linear or anything like that. There's absolutely no relationship between the two. The number of siblings somebody has no relationship to the number of pets that they have. So compared to here, my miles per hour is going to be directly related to my miles per gallon. One thing that you learned in Algebra 1, or probably even before that, to be honest, is that the x-axis is always called your independent axis, and the y-axis is your dependent axis. So whatever is happening on the x-axis happens on its own, but whatever happens with the y-axis relies down to here, whatever's happening here. They're reliant upon each other in a good, proper graph. Okay? And in this case here, my number of pets does not rely upon my number of siblings. So when I have something like this, it's going to get me something way scattered. It's just not going to make a whole lot of sense at all. All right. So now if I go ahead, when analyzing a display of bivariate statistics, remember from last semester, bivariate statistics means that there's two variables in my statistics. You need to consider the following. Form. Does the graph exhibit a linear or nonlinear pattern? Direction. Does the graph exhibit a positive relationship, a negative relationship, or neither? Relative strength. Are the data points tightly clustered along a line or curve, strongly associated, or are they more scattered, weakly associated? Okay, so using these guidelines, analyze the following graphical displays. Conduct your analysis in the context of this situation. So if I go ahead and look at this first graph here. So it says it's or not mine, but husbands and wives' ages. So here we have our husband's ages, and here we have the wife's ages. So it seems to be kind of having a positive relationship, right? It looks like here we've got those in their mid-20s and 20s, or husbands are there and matching with the wives in their 20s. Same thing here, 30s and 30s. So it's a bit more predictable. You have some that are a little bit of outliers here, like this 40-year-old dude who's got like a about 27-year-old wife. I mean, you've got those. You've got some that are just not kind of following along the pattern, but generally speaking, it is a positive relationship, and that makes sense if you consider what you've seen in the majority of life is most husbands and wives tend to be close in age. And then if we go ahead and look here at this next one, when we're looking at this one here, age of runner. So as my age increases here, our average miles per hour are actually decreasing. And this is talking about how fast somebody is going. So as somebody is getting older, does it make sense that they would get faster? I mean, it makes sense that they'd get faster if you're comparing like a 2-year-old to like a 16-year-old, but I don't know. Some toddlers can be pretty fast. Um, but you know, when you're looking at that, but if you're comparing like a 50-year-old to a 30-year-old, well, yeah, the 30-year-old most likely is going to be in better physical capability and able to do that than the 50-year-old. But so what it's showing us here is that as the runner ages, the average miles per hour is going to decrease. So now that we've looked at that, let's talk about what that means in relation to these three questions: the form, direction, relative strength. So the form on this one right here seems to be that it seems to make a linear bit of a relationship here. I could draw a bit of a line through here and I'm gonna hit a good amount of those points. So it does definitely follow a linear pattern. Um, the direction, well, this direction of this graph is positive. I have a positive slope because remember, um, little little hack, if you can't remember which one's positive, which one's negative, the way to remember that is if I have two lines like this, I've got those two, and if you want to figure out which one's positive, which one's negative, one of them makes an N. That's an N. N for negative. So a negative relationship would look like this, whereas this one is a positive relationship. So it looks like this. So that's where we get the positive relationship. So as a husband's age increases, as does the wife's age. Over here on this one, it has a negative relationship, but it's not really abundantly clear that it's negative because it is so scattered. So yeah, I mean, I can go ahead and I can draw a line through this and kind of see that that's what the pattern is kind of following as it's going along that way. But it's harder to see because these things are so far out. So then this other one over here on the right, that one's going to be negative, right? So let's go negative. Because if this one's positive over here, then this one's going to be negative over here because, again, it matches what this one is doing right here. So this is negative. Now, this one was strong because all of the points were really close together to this one. This one is going to be weak. It's weak because it's really far scattered out. It's not like it's not really clearly negative. If it was clearly negative, so like a strong negative would be just, you know, having it just be a whole bunch of things just clearly going in a decreasing pattern like that. That would be something that would just get me, you know, just decreasing. Very clear. And it's not at all going to be anything that's anything to be guessed about. Okay. All right. So now let's look at this. All right. Following graph illustrates the fact that for a designated filing status and taxable income level, the amount of tax owed depends on the number of children. Does this sound like a cause and effect relationship or simply a matter of an association between the variables? So let's consider what we have here. So cause and effect. The tax code is designed so that each additional child reduces the amount of tax owed. Um, it's literally how it's written out to be, is that as you get more children, you're going to owe less in taxes, in terms of having the same exact equitable income. If I'm comparing $50,000 income to $50,000 income. Now it's different if I was comparing $50,000 income to somebody with like a $750,000 income. Obviously, the tax amounts owed would be different. But here, if I'm just looking at what we have here, it is cause and effect because the number of children that we have directly causes the amount of taxes owed to decrease. or in essence could increase comparing from one to the other if I was comparing from having four children to having one. But that's what you have right there. So it is a cause and effect association. Um, if it was just a association, it would just be one of those things where it's like, oh hey, look, that just kind of happened, but one didn't cause the other. Just kind of worked out. The graph shown below illustrates that in general, older men have wives about their age and younger men have wives about their age. Does this sound like a cause and effect relationship or simply a matter of an association between the variables? Well, quite frankly, that's not going to be cause and effect. A husband being 60 doesn't cause his wife to also be 60. No, it's just that's an association. The husband's age doesn't cause anything to change, and the wife's age doesn't cause the other one to change. It just happens. And honestly, it happens because you have things in common with people that are around your age, a lot more things in common. You don't have right now at 18 years old, you don't have a lot in common with somebody who's 40 or 50 years old. Just like I myself don't have a whole lot in common with a 20-year-old or a 60-year-old, so that's just kind of how it works out. So it's just an association. One is not caused by the other, whereas up here, the amount of tax owed is caused due to the number of children. All right. Now, a news report noted as men age, they begin to run slower. Does this report imply that cause and effect or association? What is your opinion on this implication? Well, it's more of an association than anything because the average miles per hour is not necessarily caused due to the runner's age, but it definitely can have an impact on things. Growing older does not cause a person to run slower. They could actually run faster as they get older, depending upon how they train. So, take me for example, I don't run. Like, no. It's not something I find enjoyable. But it is something that, I've said, I should give it a fair, shot. And so if I actually did start to run and actually work out and train and everything, well, sure, I could actually go a whole lot faster than I do right now. Because right now, I tell you what, my 4-year-old can definitely run faster than me. So, in my opinion, I would say that this is more of an association than a cause and effect. Um, but it could be argued either way. And that's kind of one of those things where this is just a opinion kind of question here. Um, a special report on the evening news exposed a startling fact. When more doctors are on duty at a hospital, more deaths occur. Does this mean that doctors are killing patients? What are some other explanations? It's funny because this is actually kind of something that is a known phenomenon, even in the parenting world, where things happen and at parties where people think somebody else is watching the kids. And that's usually like there could be a whole bunch of people around and a child drowns because everybody thinks somebody else is watching the kid. Um, so what's going on here? So are doctors killing patients? No, truly what's probably happening is you have um, a larger hospital. Okay, so if you have more doctors on duty, that means it's going to be a larger hospital than a smaller hospital. And so if you have a larger hospital, that means it's going to be in a larger area and you have a larger demographic of people that you're going to be pulling from. So there could be a lot more things that happen. So there's a lot more patient potential. So you have all of that, plus all the people, injuries, sickness, car accidents, all of that stuff. So you've got all of that going on. Let's see. Explanations can you think of? I'm sure that there's other ones. I could say that it would just be, if there's a whole bunch of doctors on duty, just like what I was mentioning about children at the pool and everything, you might think somebody else is handling the situation, the scenario that is happening, and somebody else isn't, and everybody else is just pass the buck on to the next person. So that actually could be exactly what's going on, but who knows? Um, in the last 40 years, spending on education has increased while SAT scores have gone down. Sketch a scatter plot that represents these trends. Does increased spending cause a drop in SAT scores, and explain your reasoning? Okay, well, let's start with this scatter plot. So go ahead and draw this. So I'm going to go ahead and label my graph here. So this would be, as it says right here, let's look at what we've got here. We're going to have two different data points that we're looking at. And it's our spending on education has increased and SAT scores have decreased. So which one's causing the other? So do you think SAT scores going down have caused spending in education to increase? No, that doesn't make any sense. But spending in education and being increased and SAT scores going down, I mean, still, that doesn't really necessarily make sense, but that's what we're going to roll with here. So we're going to say that our dollars spent right here, and that would be with our SAT scores over here. So this is how we've got this. And then we're going to show here is as the SAT scores have gone down, okay, our spending in education has increased. So as we have high spending in education, are we up here or are we down here? Well, as it's increasing, the scores are decreasing. So it would be something like this. There. So as our money increases, so as our spending on education increased, SAT scores went down. Okay. So let's explain the reasoning. So if our spending has increased, well, it doesn't say on here that that's going to be indexed for inflation, because with inflation, obviously spending is going to increase because things cost more now than they did 20 years ago, than they did 40 years ago. Good Lord, holy cow, do they cost more than they did 40 years ago? But, obviously spending is also going to increase because we have various different things that we're paying for within education now that we didn't used to have to pay for, like technology. So with that, after you're paying for all the technology and stuff, yeah, that's going to increase your amount spent. Now SAT scores could also be going down because if you consider 40 years ago, well, you didn't necessarily have everybody and their brother taking the SAT. Whereas now, if you're taking the SAT, like we have an entire day at RHS where we take the SAT. It's not like that in a lot of other schools. Some schools, you don't get that opportunity. When I was a student, 20 years ago, I'm gonna say only 20, but it was a little bit more than that. You didn't have a day in school devoted to just taking the SAT or PSAT or ACT, none of that. You had to do it on your own time. And so there were fewer people taking the SAT 40 years ago as opposed to now. So when you have a whole bunch of people taking it, and let's be honest, does everybody who takes it at school necessarily want to take it and do it judiciously, or do some of them just bubble in whatever and finish it? So that's going to skew those results as well. So I'm sure that that's going to be some of the causes for that to be different. Last question. Doctors have become concerned about the effect of backpack weights on students' backs. Studies showed that in general, students weighing more carry heavier backpacks. Write an analysis of the situation for this school newspaper. Clearly indicate in the analysis whether this is a situation of cause and effect or association. Um, so does somebody being older or what does it say? So, sorry, weighing more. So students weighing more, they carry heavier backpacks. Okay. So if a student's 200 pounds, is their backpack going to be heavier just because they're 200 pounds? No. Um, same thing where like, okay, you compare my kid. Okay, he's 60 pounds. His backpack is not going to weigh a whole lot because, well, he's only 60 pounds. He can't carry a whole bunch. But is that the reason that his backpack is is not heavier? I guess that's not the best way to word this. What I'm trying to get at here is that as your weight is increasing, the backpack's weight is also increasing. They're not related to each other. The weight of the backpack is not directly caused to the student's weight. I will say, though, that if somebody is weighing more, then there's a chance, what if they're really muscular and they can carry more stuff? Obviously, the older that you get, the more that you're going to weigh. So you're going to have, some middle schoolers, 100 pounds, not carrying a whole bunch around, but then you have high schoolers that have more things that they're having to carry around, and that's where, you're getting a heavier backpack. It's that as you get older, you have more need to have more things in your backpack. Now I will say that that's somewhat dated because I mean, it's not like you guys are carrying around 5, 6 textbooks like we did when I was in school. You don't have textbooks really, except for a few classes here and there, and so your backpacks aren't necessarily going to be exceptionally heavy. But once upon a time, that was definitely a thing. So, all in all, though, this is going to be an association. And the reason it's an association is because the backpack weight is not going to be caused due to the student's weight. They're not related. They're just associated with one another. That's the gist here. Okay, so hopefully this all makes sense to you guys.